Go.
Hello, my dear students, and I want to quickly cover the material that we covered today for the virtual students and for my sophomores who are out taking the ACT Aspire. I'm going to post something today and tomorrow on our latest unit where we continue to deal with moles and mole relationships. So, if you look on your classroom stream, you will find our lecture summary and lecture notes right here. And if you pull them up, there are several ways to do it. That's one way. I'm trying to do it without opening a new page. But if you pull them up, they will look something like this. And I will quickly cover what's essential. And one of the things we have is a problem. We talked about the mole last week. And, here's a mole of copper. Here's a mole of aluminum. And moles are what we use to measure quantities of matter. This mole of copper weighs 63.546 grams. The big red numbers there correspond to grams per mole. This piece of aluminum weighs 26.98154 grams. And so, I can easily do that. If I have a bunch of aluminum, I don't know how much a mole is, but I can easily go to my balance and weigh out 26 grams. And so, one of the things we need to be able to do now is to convert back and forth between mass of a substance and moles present. And tomorrow I'm going to show you and talk to you about a reaction where I take a couple powders, sugar, sucrose, table sugar, and potassium nitrate, and make rocket fuel. It's sometimes called R candy, rocket candy. That is a mixture of potassium nitrate and sugar that burns and produces carbon dioxide and water and produces gases. And of course, the small volume of solid rocket fuel expands into gases very quickly. And I have a sample bottle right here of some potassium nitrate. And one of the things is I can't measure out a mole of this. I want to add a mole of this for every mole of that. But they have different densities, different molecular masses, molecular weights, formula weights, whatever you want to call it. And so I need to make those conversions because I don't know what a mole of this looks like, but I do know that I can go to my balance and weigh out a mole. The question is, how much does a mole weigh? Well, last week we talked about how you calculate the molecular weight. In this potassium nitrate, KNO3, I have 1 K, 1 potassium, with a molecular mass of 39. That's taken right off the periodic table. 1 nitrogen with a molecular mass of 14.00 something. And 3 oxygens with a molecular mass of 16, 15.9994. But we'll call that 16. And when I add it up, I get 101. And there's another thing I can do. Anytime I have a bottle of something, I can just look on the side of the bottle. This one says formula weight 101.11. There's my grams per mole on my bottle. If I want a mole, I weigh out 101.1. What if I want 2 moles? Well, there are some calculations we can do to get there. So, if I want 2 moles, I use this equation, and it will give me the mass in grams to go weigh out. Mass in grams, the molar mass, the molecular weight, the formula weight, whatever you want to call it. I frequently call it molecular weight because that's the way I was raised, but it's technically a molecular mass. And if I have a certain number of grams, I buy this bottle, they don't sell it by the mole, they sell it by 500 grams. How many moles is that? If I want to know how many moles that is, I can take my mass, 500 grams, and then multiply it by this conversion factor. And remember, these conversion factors are equal to 1. They're equalities, they're unities. 1 mole is the same as, for potassium nitrate, 101 grams. Or 101 grams of potassium nitrate is the same as 1 mole. So it's 1 over 1. And I can flip it around to meet my purposes. I'll say more about these equations in a minute. Let's look at 2 examples and we're done. Aluminum oxide. We used to have aluminum lawn furniture. It would get a white powder on the top, that's aluminum oxide. That was good because that powder actually protected it from further oxidation and further breakdown. And this is converting moles to mass. What's the mass of 9.45 moles of aluminum oxide, Al2O3? Well, I go over to my periodic table and I look up aluminum. It's a light metal, 26.98154 grams. I need 2 of those. And oxygen, 15.9994, 16.00. I need 3 of those. I add those up and I get a molecular weight of 102.0 grams. So I use my formula. I write down what I know. I have 9.45 moles, and it's 102.0 grams of aluminum oxide per mole of aluminum oxide, and I end up with 964 grams. I can also convert mass to moles. If I'm given the mass, the question is how many moles? So here's rust, iron oxide, iron 3 oxide, Fe2O3. I have 92.2 grams. How many moles is that? Well, once again, I need my formula weight, my molecular weight, my molecular mass, my molar mass. So 1 mole of iron oxide, I go to my periodic table, 2 irons, they're 58.4, I forget the exact amount, 55.847 grams per mole. And I go up to my oxygen, and it is 15.9994 grams. You can use 16, that'd be fine. But when you add it up, it adds up to 159.6 grams per mole. So I write down what I know, 92.2 grams per mole. I want my grams to cancel, so I put my grams in the denominator. This is an equality. I'm multiplying this value times 1. So 92.2 grams is equal to, when you do the math, 0.578 moles. Tomorrow, we are going to talk about making some conversion with gases. But if I go back to the slide where I lost you, when I put up a slide like this, immediately everybody's eyes roll back in their head and they forget what they're doing. You don't have to remember these formulas. You don't have to do that. I'm going to be handing out, and you are going to be working with a mole map. I'm going to, we're going to do the assignment together tomorrow. So when you go to your classwork and you open up this assignment for today, you will see the assignment and something called a mole map. So what is a mole map? Well, let me show you what a mole map is. I have a picture of it. There's one of these on every benchtop, and it's present in 2 different versions, but I have a very visual version of it. It looks something like this, and it's a mole map. And this mole map simplifies remembering those equations. You don't have to remember them at all. And you'll have this when you do your homework. You'll have this on a test. On a mole map, if I am given a mass and I want to convert to moles, I multiply. You always multiply. I follow the arrows and I multiply by 1 mole over the molar mass. I may have to add up some molecular weights to some atomic masses to get my molar mass. but I just multiply. If I'm given moles and I want to go to mass, I multiply by this value, the molar mass per mole. This time I, go in the other direction, I use 1 mole is equal to this molar mass. And we already did some example problems where we converted back and forth between moles and number of atoms or number of representative particles. And tomorrow we'll do a conversion between moles and volume of gases. So, if I can, I will just say, don't worry about that homework assignment. We're going to do it together tomorrow, and I will work some sample problems for you or show you how those problems are worked. And we will complete our discussion of mole conversions, mole interconversions, and the mole concept by talking about, the relationship between moles and the volume of a gas. And I will form a gas and basically do a controlled explosion, a very rapid burn of sugar using potassium nitrate. And we'll make some more comments about it tomorrow. Until then, I will see you in the next video, and stay safe.